Hello and welcome to Techonomy Hub, where technology meets business growth. Discover how the latest tech tools and strategies can empower your business and shape your future. Please subscribe and share to support us. Quick question: which tech trend could boost your business most? What does it truly mean to own Bitcoin? For many, the word conjures images of volatile charts, speculative trading, and complex code. But beneath the surface-level noise, a fundamental shift is occurring. Businesses, investors, and forward-thinking entrepreneurs are beginning to pay very close attention to. Owning Bitcoin is not like owning a stock or holding cash in a bank account. It represents a new form of digital property, one defined by mathematical proof rather than institutional promises. It's a system where control is absolute, transactions are final, and intermediaries become optional. This distinction is critical because it forces us to rethink our foundational concepts of value, trust, and financial sovereignty in a digitally native world. Welcome to Techonomy Hub, the channel where we bridge groundbreaking technology and practical business application. Our mission is to demystify complex topics like blockchain and digital assets, equipping you to thrive in the evolving digital economy. We don't focus on hype or get-rich-quick narratives. Instead, we dissect the underlying mechanics of these systems to reveal how they are actively transforming business operations, financial infrastructure, and the very nature of trust. We believe that understanding the how and why behind a technology like Bitcoin is the first step toward unlocking its strategic potential for your enterprise, career, or investment thesis. In today's exploration, we will move beyond the headlines and dive into the core principles of Bitcoin ownership. You will come to understand this pioneering technology not as a fleeting trend, but as a meticulously designed system that could fundamentally reshape how money moves and how trust is established on a global scale. This is not a technical manual filled with jargon. It is a business-focused guide designed to give you a strategic advantage. We will translate abstract concepts into tangible insights, showing you how cryptographic control, decentralized ledgers, and digital scarcity can create real-world value, reduce operational friction, and open up new commercial possibilities that were previously unimaginable. The journey we are about to embark on is designed to empower you with a clear and durable understanding of a technology that is increasingly relevant. By the end of our discussion, you will be able to confidently explain how Bitcoin ownership works, why it matters for modern business, and how its core components are laying the groundwork for the next generation of finance. The insights you gain will enable you to look at the digital landscape with a more informed perspective, separating the substance from the speculation, and identifying genuine opportunities for innovation and growth. Let's begin to unravel the secrets that smart businesses are already leveraging. Okay, let's go. Why traditional systems are limited. Problem grows when transactions cross borders. Moving money requires a web of correspondent banks. Each adds another point of failure. Transactions are subject to each jurisdiction's policies. Sudden political or capital control changes can disrupt supply chains or payroll. A business's financial autonomy becomes conditional on external permission. This is the core dilemma smart businesses confront. The system forces a trade-off between participation and financial sovereignty. Convenience costs control, concentrated with a few gatekeepers. Operational agility, global reach, financial survival, all contingent on third-party approval. This fundamental limitation, centralized control, has fueled the search for an alternative. A system where ownership is absolute and activity isn't predicated on intermediary permission. That's the challenge. The shared ledger concept. To understand the innovation of Bitcoin, we must first envision a simple yet powerful idea: a shared digital ledger. Imagine your business collaborates with several partners on a joint project. You need to track shared expenses, contributions, and payments. The traditional approach: a central spreadsheet managed by one party, emailed back and forth. But this immediately creates problems. Who controls the master version? Who can alter entries? Every time an update is made, a new version must be circulated, causing confusion, version control nightmares, and a constant need for reconciliation. This highlights a core challenge: establishing a single, agreed-upon source of truth. The shared spreadsheet is flawed because it relies on trust. Each partner must trust the central administrator, trust the accuracy, and trust the version they see. That trust is fragile and inefficient. It requires constant communication, verification, and manual checking, all consuming time and resources. The process is prone to human error, disputes, and potential fraud, creating friction and damaging relationships. Now, reimagine the ledger. Instead of a copyable file, imagine one magical notebook everyone sees at once. When someone adds an expense, it appears instantly for everyone. Once written, an entry cannot be erased or changed. It can only be appended. This builds a permanent, unchangeable history of project finances. No master copy, no central admin. The notebook is the single source of truth, shared and synchronized automatically. This is Bitcoin's shared ledger. The blockchain. It lets records be maintained where participants don't necessarily trust each other. It replaces a trusted central party with shared record-keeping, transparent record-keeping, and immutable record-keeping. By giving a common, undeniable view of transactions, it removes ambiguity and conflict from spreadsheets. A foundational shift from trusting people to trusting a shared, verifiable record. Digital ownership with cryptography. Now that we have established the concept of a shared ledger, we must answer a critical question. If everyone can see the ledger, what stops someone from adding a transaction that spends your money? The answer lies in cryptography, specifically in digital signatures, created using a pair of cryptographic keys. Every participant on the Bitcoin network has a unique pair of keys, a public key and a private key. These keys are mathematically linked, but the private key cannot be derived from the public key. This one-way relationship is the cornerstone of security and ownership, forming the foundation of control over your assets on the ledger. The public key is public. It's safe to share. You must share it to receive funds. Think of your public key as your bank account number, posted on your website, or printed on an invoice. When someone sends you Bitcoin, they create a transaction that directs value to an address derived from your public key. Your public key is your identity on the network, a destination for funds. It lets you receive value without revealing any secret information. The private key is the most important secret a Bitcoin owner has. Keep it completely confidential, never share it. If the public key is your bank account number, the private key is like the secret PIN, the password, the signed withdrawal slip, but far more powerful. The private key authorizes spending for its corresponding public key. It's the mathematical proof of ownership. Whoever controls the private key controls the Bitcoin at that address. Digital ownership with cryptography. So, how does the private key actually exert control over the funds on the public ledger? It does so through the creation of a digital signature. When you want to spend Bitcoin that has been sent to your address, you must create a transaction message. This message contains details like the amount you want to send and the recipient's public address. However, this message alone is just a proposal. It has no authority. To prove that you are the rightful owner of the funds you wish to spend, you must sign the transaction using your private key. This act of signing is a mathematical process, not a handwritten signature. The signing process takes your unique private key, the specific details of the transaction message, and combines them to produce a unique digital signature. This signature has two crucial properties. First, only someone with the corresponding private key can create it. It is mathematically impossible to generate a valid signature without it. Second, the signature is unique to that specific transaction. If even a single detail, like the amount or the recipient, were to change, the digital signature would be completely different. This prevents anyone from taking your signature from one transaction and trying to apply it to another. Once the transaction is signed, it is broadcast to the entire Bitcoin network for verification. Anyone on the network can then use your public key, which is also public knowledge, to verify the signature. The verification process mathematically confirms two things: that the signature was indeed created by the private key linked to your public key, and that the transaction message has not been altered in any way since it was signed. If both checks pass, the network accepts the transaction as valid and includes it in the shared ledger. This is how the network enforces ownership without needing a central authority. It doesn't need to know who you are, only that you hold the secret key. This cryptographic process is the core of what makes Bitcoin transactions so secure. It allows you to authorize the movement of your assets without ever revealing your private key to anyone. Not to the recipient, not to the network, not to anyone. Your private key is used to generate the signature on your own device, but the key itself is never transmitted. This is why the central message for any business is so clear. Ownership in Bitcoin is not physical, it is cryptographic control. Your power to transact is derived entirely from your exclusive possession of that secret key, and the act of signing is the exercise of that power. From records to digital currency, we have established the concepts of a shared ledger and cryptographic ownership through private keys. But a list of records, no matter how secure, is not money. The crucial transformation happens when ledger entries are recognized as transferable value. In Bitcoin, the ledger does not track external objects like dollars or euros. The entries themselves, the units recorded at addresses, are the asset. This is a fundamental shift. The value is not an IOU for something else. It's inherent to the ledger entry. For this system to function as money, the units must be scarce, divisible, portable, and fungible. The Bitcoin protocol establishes these properties through its code. Scarcity is programmed via a fixed supply cap of 21 million coins. Divisibility: each Bitcoin can be broken into 100 million satoshis. Portability: millions of dollars can move across the globe in minutes with an internet connection. The double spending problem. In the physical world, this problem doesn't exist. If you have a $10 bill and you give it to a merchant to buy a coffee, you no longer have that bill. You cannot go to the store next door and spend the exact same $10 bill again. The physical transfer of the object prevents it from being used twice. However, in the digital realm, anything can be copied perfectly. An email, a photo, a music file can be duplicated and sent to multiple people simultaneously at virtually no cost. If a digital currency were just a file on your computer, you could easily copy that file, send one copy to a supplier for an invoice payment, and simultaneously send the other copy to an employee for a salary payment. This would be equivalent to counterfeiting, instantly destroying the integrity and value of the currency. The ability to spend the same digital money more than once would lead to a complete collapse of trust in the system. No one would be willing to accept a digital payment if they couldn't be certain that they were the sole and final recipient of that specific value. This is the double spending problem, and its solution is the key to creating legitimate digital money. Traditional financial systems solve this problem using centralization. When you swipe your credit card, a central authority, like Visa or your bank, maintains a private, authoritative ledger. They check your account balance, confirm you have sufficient funds, debit your account, and credit the merchant's account. This central party acts as the trusted gatekeeper, ensuring that you cannot spend the same funds twice. Their role is to update the one and only true ledger and prevent any conflicting transactions from being processed. This works, but as we've discussed, it relies on a trusted intermediary, with all the associated costs, delays, and risks. Bitcoin's challenge was to solve the double spending problem without a central authority. How can a network of strangers, who don't trust each other, come to an agreement about which transaction is valid if two conflicting ones appear? If a malicious user tries to send the same Bitcoin to two different recipients at the same time, How does the network decide which payment to honor and which to reject? The solution had to be built into the protocol itself, allowing the network to achieve consensus on a single, shared history of transactions. This would require a revolutionary new approach to consensus, one that did not rely on a single point of control. That's the core dilemma the system needed to overcome. Decentralization and trustless systems. Bitcoin's elegant answer to the double spending problem is decentralization. Instead of one central entity in charge of the ledger, the network distributes the ledger across thousands of computers, or nodes, around the world. Every node keeps a full copy of the transaction history. That radical distribution means there is no single point of failure, no central administrator who can be coerced, corrupted, or shut down. Authority once held by a bank or payment processor is now shared among all participants, creating a resilient, censorship-resistant system. When a transaction is broadcast, it propagates across the network. To become permanent, it must be included in a block of transactions and added to the shared chain. Any node can propose a new block. This is where the magic happens. To prevent double spending, the network needs agreement on which block is valid. That's achieved by a consensus mechanism, which makes creating blocks computationally difficult and economically rewards honest behavior. For businesses, this reduces counterparty risk. No central institution can fail and freeze your assets. The network runs 24/7, governed by predictable mathematical rules, not shifting corporate or government policies. That gives operational certainty impossible in traditional finance. A business can be confident. If it broadcasts a valid transaction, it will be processed without third-party interference. Decentralization also creates a permissionless environment for innovation. Anyone, anywhere in the world can connect to the Bitcoin network, hold assets, and build services on top of it without asking gatekeepers for approval. This unlocks access for underserved populations, enables new global business models, and removes legacy financial friction. The network becomes a neutral, global utility for value transfer, reducing dependence on traditional institutions and paving the way for a more open and inclusive financial future, including decentralized finance, or DeFi. Blockchain and proof of work. Explained, decentralization alone is not enough. The network needs a mechanism to agree on the ledger's state securely. This mechanism in Bitcoin is called proof of work, or POW. It's the engine that drives consensus and secures the blockchain against attack. Proof of work requires miners to perform a computationally intensive task to earn the right to add the next block. They repeatedly guess a number until they find one that, when combined with the block data, produces a cryptographic hash or a digital fingerprint that meets specific difficulty criteria. It's like a global lottery. Miners use specialized computer hardware. They generate trillions of guesses per second. Finding the correct number is incredibly difficult. It requires massive processing power, and therefore, electricity. But once a miner finds the solution, it's trivially easy for the rest of the network to verify. Hard to find, easy to verify. The first miner to find the solution broadcasts their new block to the network. Other nodes verify and accept it as the next valid block. They then begin working on the block that will follow it. This work serves two critical purposes. First, it secures the network. To alter a past transaction, an attacker must redo the proof of work for that block and all subsequent blocks, all while the rest of the network keeps building on the original, honest chain. That would require more computational power than the entire network combined, making the ledger practically immutable. The energy spent by honest miners creates an economic and computational wall protecting the blockchain. It makes cheating prohibitively expensive. Second, proof of work provides the incentive for miners to participate and act honestly. The miner who finds a block earns newly created Bitcoin, the block reward, plus all transaction fees from the transactions included in their block. This economic incentive encourages miners to invest in hardware and electricity to secure the network. They are financially motivated to follow the rules, because cheating would get their block rejected and they'd forfeit the reward. What ownership really means. By combining a decentralized network with a proof-of-work consensus mechanism, Bitcoin achieves something remarkable. It replaces the need for institutional trust with trust in mathematics and economic incentives. You no longer need to trust a bank's reputation or a government's promise. You can trust a system whose rules are transparent, whose security is guaranteed by the laws of mathematics, and the rational self-interest of its participants. This is the ultimate business insight. Trust is replaced by math and incentives. The system is designed so that it is more profitable for everyone to cooperate and play by the rules than it is to try and cheat. Business insights and takeaways. It's not what you think. Truth 1. Bitcoin today is a settled global value network. Businesses use it for cross-border settlement, B2B invoices, and Lightning for instant retail and micropayments. Truth 2. Ownership equals key control, full stop. Custody has matured. Self-custody, multi-sig, and enterprise custodians, plus KYC on and off ramps, and auditability from a transparent ledger. Truth 3. Volatility is a treasury question. DCA, hedge windows, segregate risk, not a blocker. And energy? Mining increasingly uses efficient waste energy capture. Incentives align with security. Takeaway: trust math and incentives. Treat Bitcoin as infrastructure, then build on it. Subscribe and share to stay ahead with Techonomy Hub. Conclusion and call to action. If you found this valuable, please subscribe and share to support the channel. Question: will your business adopt Bitcoin this year? Stay ahead with Techonomy Hub. Thanks for watching.